Hi, good morning everyone. Today we are going to discuss the solutions of the exam which I took on the topic algebraic expressions and square roots. So let's start. Question number one. What is the unit digit of the square of 799? So I have to find the unit digit of this number of this square, right? So we know how do we solve this. So we take the number and find the last digit. So last digit is 9. I will do the square of this last digit, which will give me 81. So the last digit of this will be the last digit of the entire number, square of the entire number. So therefore the answer is 1. Okay, let's move to the question number 2. Check if 7928 is a square number or not. 7928 is a square number or not. Okay, is a square number or not. Very easy. The first step is always to check the last digit of the number. If the last digit is 2, 3, 7, and 8, then the number is not a square number. So I can see that this number is ending with 8. That's why this is not a, therefore this number is not a square number. Okay, therefore this number is not a square number because it is ending with 8. Let's move to the question number 3. Mm. Without adding, I have to find the sum of 1 plus 3 plus 5 plus 7 plus 9 up till plus 23, right? Here you have to directly use the property. What is the property? The sum of the first n odd numbers is n square, right? So how many odd numbers we are adding here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 between 1 and 23. There are 12 odd numbers. So I am adding first 12 odd numbers. Therefore, the answer will be 12 ka square, because the first and odd number is what? N square. So it will be 12 ka square, which is 144. Okay, and that's the answer. 144 is the answer. Let's look at the question number 4. Find the square roots of the following numbers using prime factorization method. So I have to find the uh, square roots of these numbers, 9216, and second is 729. So let's start with 9216. You have to do the prime factorization of these numbers. So let me write it here. 9216. 2 4s are 8, 2 6 are 12, 2 8s are 16, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 1s are 2, 2 1s are 2, 2 5s are 10, 2, then 2 5s are 10, 2 7s are 14, 2 6 are 12, 2 2s are 4, 2 8s are 16, 2 8s are 16, 2 1s are 2, 2 4s are 4, 2 4s are 8, 2 7s are 14, 72, 2 3s are 6, 2 3s are 6, 2 6 are 12. Again, it can be divided by 2. Last digit is even. 2 ones are 2, 2 eights are 6. Again, divisible by 2, 2 nines are 18. Now 9 is not divisible, so it can go by 3. 3 ones are 3. So it is such a big uh, prime factorization. So I can write 9216 is equals to 2 into 2. How many times I am multiplying? 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into 3 into 3, right? Now my second step would be to make the pair of all the prime factors. So here 2 is there. So I'm going to make a pair of 2, 2, 2, 2, 2, 3. Now since I have paired them, I'm going to take one number from each pair. So here is 2, taking 2 from here, 2 into 1 from here, 2, 1 from here, 2, 1 from here, 2 into 3. My final answer will be 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 3s are is 96. So answer is 96. The square root of 9216 is 96. If you have written this answer, your answer is correct. Now let's go to the second, 7 to 9. Second question is 7 to 9. Again, we have to do the prime factorization of this number 7 to 9. Since the last digit is not an even number, so I have to check for the divisibility test of 3. When I do that, 7 plus 2, 9, 9 plus 9, 18, 8 plus 1 is 9. So it means that this is divisible by 3 because 18 is a multiple of 3, right? So 3 to the 6, 3 4s are 12, 3 3s are 9. Again, I will check 4 plus 2, 6, 6 plus 3, 9. Again, divisible by 3. 3 is a 24, 1. 8 plus 1, 9. Again, divisible by 3. 3 to the 6. 3 sevens are 21. 7 plus 2, 9. Again, divisible by 3. 3 nines are 27. 3, 3, 3, 1. Right? So now I can write 729 as 3 into 3. How many threes are getting multiplied? 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6. Now I'm going to make the pair. One pair, second pair, third pair. From each pair I have to take one number. So 3 into 3 into 3, which will give me 3 3 are 9, 9 3 are 27. So now 27 is the square root of 729. Okay, that's your final answer. Great. Let's move to the next question, which is question number 5th. For number 180, what is the smallest number which should be multiplied for the number 180? What is the smallest number that I should multiply? Smallest number to be multiplied so as to get a perfect square. So I have to make this number as a perfect square. Now they are asking what should I multiply here so that my answer should be a perfect square. Okay. To do such type of questions, what we do is first step is again prime factorization. And why am I doing the prime factorization? Let's see. 0 is the last digit, so it's an even number, so I can divide it by 2. 90, 2, 45, 5 nines are 45, 3 threes are 9, 3 ones are 3. So the 180 can be written as 2 into 2 into 3 into 3 into 5. Now, can you tell me whether this number is a perfect square or not? No, it's not a perfect square because 2 is in pair, 3 is in pair, but 5 is not in pair. So as to make this a perfect square, I have to make 5 in pairs, right? How can I do that? I can multiply 180 with 5 so that if I get one more 5, then this number can become a perfect square. So what I have to do? I have to multiply 180 with 5 so as to make this number as a perfect square. So 5 zeros, 8 fives are 49, right? So the smallest number which I need to multiply is, you can write it here, smallest number to be multiplied is 5, right? That is your answer. Let's move to the question number 6. Wait, let me just clear the canvas. Mhm. Now let's do question number 6. There they are asking subtract 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10. I have to subtract this algebraic expression from this algebraic expression. 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q. Okay, so this algebraic expression has to be subtracted from this algebraic expression. Okay, these needs to be subtracted from this. So what I have to do, I'll just write the subtraction operator. 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q minus, I have to subtract this algebraic expression, so I'm going to write it here. 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10. Okay. Now, I'm just going to simplify this. That's it. So what I'm going to write, 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q. And now this minus sign is going to get multiplied to each term of the second algebraic expression. So minus into plus will give me minus 4p square q. Minus into minus will give me plus 3pq. Minus into plus will give me minus 5pq square. Minus into this minus will give me plus 8p. Minus into plus will give me minus 7q, and minus into minus will give me plus 10. Okay. After doing this, what I have to do, I have to find the variable term of variable part of each term. This is constant. This is p, q, pq, pq square, p square q, p square q, pq, pq square, pq, and this is constant. So now what I have to do, I have to group the similar terms. So first I will start with the constant. So 18 I have included this, and 10. Is there any other constant I can find? No. So I'll write 18 plus 10. Now plus I will write p, the like terms which has p as the variable. So minus 3p included, and 8p plus 8p. Any other thing which is included? No. Now let me include q, the like terms which has q as a variable. Minus 11q, done, and minus 7q, right? This is done. Then just include the variable terms which has pq as the variable. So 5pq. Then what else is plus 3pq, correct, included. Now let's include pq square terms. So minus 2pq square. So this is included. Which else is pq square? That is p into q into q. This is the one which is pq square. So I'll get right minus 5pq square. And at last, what is left? P square q plus 5p square q minus 4p square q. Okay, so I have grouped all the like terms together. Now, once I have grouped, what I'm going to do, I'm just going to simplify them. 18 plus 10 will give me 18 plus 10 will give me 28 plus minus 3 plus 8p minus 11 minus 7q plus 5 plus 3pq plus minus 2 minus 5pq square plus 5 minus 4p square q. Okay, then the answer would be 28 plus 8 minus 3 will give you 5p. Minus 11 minus 7 will give you minus 18q, 8pq, minus 7pq square plus 5 minus 4 will give you 1p square q. That is your answer, guys. Okay, so please look at all the steps, and this is the answer. Now let's move to the next question. Multiply the following algebraic expression. So you have to multiply here. So question number 7, first part, what I have to multiply? 3p with 4p square plus 5p plus 7. So you know how do we multiply this? We are going to, so basically we have to do this. I'm going to multiply 3p with the each term of this expression. So it's going to multiply with each term of this algebraic expression. So it will look like 3p into 4p square plus 3p into 5p plus 3p into 7, which will give me 4. Now what? How do we multiply? First we multiply the constants term together. So 4 into 3, 4 is at 12, and now I'm going to multiply the variable parts. P into p square will give me p raised to power 3. How did I do this? You know that a raised to power m into a raised to power n is equals to am plus n. So here the power is 1, here the power is 2, base is same. So I've just added the powers, right? Plus 5 3s are 15, p square, here power is 1, 1. So 1 plus 1 give me 2. 7 3s are 21, p. So my answer is 12p cube plus 15p square plus 21p. Okay. Let's look at the second part of the question. I have to multiply x minus 4 and 2x plus 3, right? Okay. So how we are going to do this? If I have to multiply the monomial with the binomial with the binomial, what we will do? We take the first term of the binomial and then multiply it with the entire second algebraic expression, and then we take the second term of the binomial and multiply it with the plus minus 4 and multiply it with the second algebraic expression. So it will look like this. So first term of the first algebraic expression getting multiplied with the entire second algebraic expression, and the second term of the algebraic expression getting multiplied with the entire algebraic expression. Now just simplify it, apply the distributive property x into 2x plus x into 3 plus minus 4 into 2x plus minus 4 into 3, which will give me 2x square plus 3x 4 to minus 8x minus 12. Okay, now what will happen here? 3 minus 8x minus 12. Why I have taken them together? Because these are like terms, so I'm just trying to simplify this. I will get 2x square minus 5x minus 12. This is your answer. Okay, great. Let's look at the next question, question number 8, which is I have to add. Let's do question number 8. It says add 2x z minus x minus y and 2y z minus y minus x. Okay, so you have to add this algebraic expression with this algebraic expression. So first of all, we will simplify both the algebraic expressions. So again, the same thing, this number is going to get multiplied with all the terms of this algebraic expression. So it would be 2x into z plus 2x into minus x plus 2x into minus y plus 2y into z plus 2y into minus y plus 2y into minus x. Okay, so it would become, just let's simplify. It will become, I'm just going to simplify and write it here, 2xz minus 2x square minus 2xy plus 2yz minus 2y square minus 2xy. Okay, now what I'm going to do, I'm going to take the like terms together. So here the constant part is xz is x square xy yz y square xy. Okay, so let's take one by one term together. So only xz, xy, yz, only this term and this term are like terms, right? No other term is a like term. So I'm just going to club them together. So my final answer would be 2xz minus 2x square minus 2y square plus 2yz minus 2 plus minus 2 give me minus 4xy. So by clubbing these two terms together, I got this minus 4xy. So this is my answer, guys. That's how you did the addition. Now let's move to the question number 9th. Let me just take down. I have to just simplify a plus b into c minus d plus a minus b c plus d plus 2ac plus bd. Okay, so I have to just simplify this. What I'm going to do, I'm going to simplify each term. So this is my one term, this is one term, this is one term, and this is a third term, right? Now first I should simplify the brackets. So a plus b into c minus d. I'm just going to write it again together. Now let's simplify. This will get, a will get multiplied to c minus d, then b will get multiplied to c minus d. Similarly here also a will get first multiplied to c plus d, and minus b gets going to get multiplied with c plus d. Then I'm just going to open the brackets here, 2ac plus 2bd, right? Here it would be AC minus AD plus BC minus BD plus AC plus AD minus BC minus BD plus 2AC plus 2BD. Okay. Now what I have to do, I have to just find the like terms. I see that AC, 2AC, somewhere else can I see AC? These are like terms. Let's find AD, anywhere AD, nowhere else is AD. Then BC, these are the only two terms. And let's take minus BD and 2BD and minus BD, correct? Now let's group them together. So I'll write AC plus AC, right? Wait, there is plus 2AC also. AC plus AC plus 2AC. Then plus minus AD plus AD plus BC minus BC plus minus BD minus BD plus 2BD. Okay. So if I do calculate this, AC plus 2AC will give me 4AC, minus AD plus AD will cancel out, BC minus BC will cancel out, minus BD will give me minus 2BD, minus 2BD plus 2BD will also cancel out. So finally my answer is 4AC. That's your answer, guys, for this question. Now the last question, question number 10th. Let's just look at it. Simplify using identities. So what is the question here? 2x plus 5 whole square minus 2x minus 5 whole square, right? If this is the question, I have to simplify it using the identities. So when I see the question, I see there are two square terms and there is a minus sign in between. So by default, I think of an identity where I'm using two square terms and there's a minus sign in between. So I get reminded of a square minus b square, and this can be written as a minus b and a plus b. Now what is a here? A is my 2x plus 5. What is my b here? 2x minus 5. So now let's use this to simplify this. So let's put these values in this equation, right? So if I put the values, it would be 2x plus 5a minus b. So a, I'm just going to make the things easier, I'll just write a plus b, a minus b, right? This is the formula. So 2x plus 5 plus 2x minus 5 into 2x plus 5 minus 2x minus 5. Okay, so let's first simplify the brackets. Here the like term is 2x and 2x. 5 and minus 5 will cancel out, so it will give me 4x into, let's do this, 2x plus 5. Now this minus sign is going to get multiplied to both the terms, which will give me minus 2x plus 5. Here 2 minus 2x and 2x will cancel out. Excuse me. 2x and minus 2x will cancel out, and what will be left? 5 plus 5, which will be 10. So my answer will be 4x into 10, which will be 40x. That is your answer for the last question. So that's it, guys. Please go through these solutions, check your test paper and see what mistakes you have done, and redo those questions again. Okay, that's it, guys. Bye.